Can you guys see this okay? I know there's a glare in the top left. There's also a little delay between when I talk and the chat. So if I pause for a long time, that's why. There's your flag of the day. So I'm going to give everybody till about 2:15 to get in. If I could just take attendance, that'd be great. So who do we have in here? I see Ken. Oh geez, that's moving so fast. All right. Mike, Patrick, Jacob, Destiny, Jim, Parthy, Tom, Dimitri, didn't have to put your entire name. Right. Yep, both Dan's. Pretty sure I saw something about a boot earlier. Is he actually in here? Good one, Ken. So I apologize for the glare, but haven't been able to completely eliminate it yet today. Noah. I'm just trying to set up a plot here while I'm giving people a chance to sign in. If you guys hear random noises or bells or anything like that, it's the cat. If you guys don't have your calculators, you may want to grab them real quick. So how's everybody doing? That is -1 to the power n. Why is this darn plot not working? Hopefully I put the wrong thing. Here we go. Can I borrow a pencil? Yeah, I'm not thinking that's going to work. I don't know what that is, Tom. I assume you're saying semester. And I do not know. Okay, so everybody can see the screen okay. And again, there's the glare in the top left. If I start to write there, just say something. If you guys are ready to go, we can go ahead and get started. I think we're missing quite a bit of people, though. Chat went away. Dan, there is no quiz to start class. I will be giving you a quiz, but I will be giving it to you online after class. Maybe not today even. So before I go on to sequences, does anyone have any questions about the last material? Thanks, Ken. I don't need your personal opinions. No, I'm just kidding. Equations be given to us for an exam. You could still have a little note card if I give you the exam online. Okay, so I keep seeing people say they didn't like stuff. Does that mean they would like me to go over one of these problems? So you want me to do the circuit problem? Whoa, way too small. Where'd my eraser get to? Okay, so I don't like that marker for some reason. Second, I lost my chat. I can see that you would use your magic notes there, Parthy. Probably not something you should tell me. So am I okay to do this problem again? Okay. There should be an example on the homework. Would you rather I do that one? Okay. Give me just a second to pull that up. Try to clean this board up some. I ventured out to get this board just yesterday for you guys. not it. There we go. Simple circuit has resistance of 10 ohms. Inductance 5 henries. Battery gives constant voltage, 70 volts. Switch is closed at t equals 0. That tells us that the current at t equals 0 is 0. Find the current after 3 seconds. Go ahead and close that. Okay. So we had that the equation was E of t equals L di dt plus IR. So we're given L is 5, E is 70, R is 10. Just plug all of those in. Ken, I didn't have this giant whiteboard in my basement before yesterday. All right, so E is 70. L is 5. And I is itself, R is 10. So 10I. So that is a differential equation that is of the form that we use for integrating factor. Remember that that's dy dx plus p of x y equals some q of x. So first I got to get the di dt all by itself. And I could do that by dividing by 5. Where's my eraser again? I keep losing it. I don't know where it went. So to do that, and what is that? 14. So I just wrote it the other way, but that's right there, that's right there, and that's over there. So then I need to find my integrating factor. So mu is equal to e to the integral of whatever's in front of the I here times dt. And that's a real simple integral. You just get t out of it. Then you take that and you multiply it by everything there. Like so. Then this side should always collapse to d, in this case it's going to be dt, of the integrating factor times I in this case. Otherwise it would be y. And we can check that, right? We can take the derivative. Derivative of I is di dt, leave the e alone. Then derivative of e to the 2t is 2e to the 2t, and leave the I alone, so that looks good. And then this equals 14e to the 2t. Move the dt to the other side and integrate. So this is the integral of d e to the 2ti equals integral, put the 14 out front, e to the 2t dt. Left hand side is really nice there. You just get I e to the 2t, right? Integral of a differential, they cancel. On the right hand side, integral of e to the 2t is 1/2 e to the 2t plus a constant. So that's really just 7 there. And then last thing is to divide everything by e to the 2t. Which is effectively multiplying by e to the minus 2t. Same thing. And then at that point, the problem just said find it at 3 seconds, so just plug in t equal 3. Any questions about that problem? You're welcome, Ken. Would c equal -7? You would have to solve plugging in. Yeah, we have to get c. So to do that, you would use your initial condition, which is t equals 0, I equals 0. So plug in 0 there. Plug in 0 there. So e to the 0. You're going to get 1 out of that. So you just get c equals -7. Yep. So you can just come up here and say that's -7. Then you would go ahead and plug in t equal 3 and solve. Yep, no problem. So on my screen, that stuff kind of looks dark. Can you guys see it okay? Good. So my class this morning went well. My class right now, students are saying they can see. My Calc with Apps class in the middle of the day said they couldn't see anything. Alright, so if it's alright with you, I'm going to go ahead and erase that. Also, I am recording these sessions, so I'm trying to figure out the best way to post them. Right now it's looking like maybe putting them on YouTube would be the best way to go. If you also know how, some of my students this morning created some clips of the talk. So if you would like to do that, you're welcome to. So yeah, this website should be able to save everything, but it hasn't. I don't know why, but it hasn't done that for me so far. Pretty much the hour before class, I was sitting here with another student trying to figure out how to do that. So, right now it's saving to a file on my computer, and then I have to convert the file and send it to you guys. So I apologize. I know that the internet's probably not the greatest avenue right now, but it's kind of all we have. So we will certainly do a review before I give you guys the exam as well. But because we don't have necessarily in-class exams, I may use that time as extra class time. So Dan, if you're having some problems, like I said, I'm going to be putting up. Yeah, that might do it. You might be having some trouble if you're leeching off the neighbor's Wi-Fi. But I'm going to try to put up the videos for you guys so you can watch them then. All right, so let's go ahead and start some new stuff. We've got sequences. Okay, thanks, Kat. We've got all that integration that we've done. That's great tools. We did the applications. Unfortunately, we have to take a little bit of a detour here and do sequences and series. This is probably my least favorite part of Calc 2. You might like it. It's easy. So let's start with sequences. So definition of a sequence is literally a list of numbers that follow a pattern. We can say that they either converge, as in they approach some constant, or they diverge, which means they approach infinity. Tom, I see you say, how will the exams be formatted? I don't know, honestly, yet. My guess is that I will try to do the same thing that we've been doing, but you'll be using an online software that uses your camera to watch what you're doing to make sure there are other people not in the room and so forth. But it is certainly going to be difficult to grade your work, not just your answers. So I have to think of some way to do that. But like I said, the test is not till next week at the very earliest, so don't worry about that yet. All right. Plot the first 10 corresponding values of each sequence. Determine if the sequence is convergent or divergent. So as I was saying, converge means it approaches a constant. Diverges means that it most likely approaches some infinity. So here's this sequence. It's -1 to the n, 2 to the n, all over n factorial. Let me see if I can make it just a little bit bigger for you. All right. Maybe that helps you read it a little bit. Let's get my chat back up here. Okay. I'm glad this is funny. I don't know what you guys are talking about. All right, so corresponding values, first 10, plot the sequence. So I've got -1 to the n, 2 to the n over n factorial. The reason I asked you to get your calculators is I wanted to teach you how to do it on there. Let me just show you what I've already done on Mathematica. So that is that sequence plotted. You'll see that the first point is actually off the screen, it appears. No, there it is. So there's a point down here for one, should be 1, 2, 3, 4, 5, right? So we would call this alternating, as in the sign changes from -1 to 1, or negative to positive. And the question is this sequence converging or diverging? So is it approaching a value, or is it spreading apart? So pretty clearly this is approaching a value, and that value is 0. So let's see if I can show you how to do this on the calculator. I don't have the software on my... Yes, it is approaching 0. Alright, so... Oh, let's see if we can get in the light here. There's your calculator. Okay. So we want to go to... First thing we want to do is go to Mode. And in Mode, you will see the 4th option down. You've got Function, Parametric, Polar, and Sequence. You want to scroll all the way over to Sequence and then hit Enter. Then when you go to Y equals, you should see something a little different. Let's see if I can get it on there for you. Come on, light. There we go. So you should see that. So under U of n, put in the sequence. So that is -1 to the n. If you press the X button, that effectively is n when you're in sequence mode. So then I need 2 to the n, and then divided by, we need n, and we need factorial. So now you're going to go to Math, go over to Probability, the 4th option on the top, and go down to the 4th option, which is the exclamation point. That is a factorial. Then when you go back to Graph, you want to make sure that you are in your standard. So Zoom standard is Zoom 6. And then you should be able to see some of those points. So I did standard, and maybe you can see those points there. If I zoom in, right, I can just do the positive axis. Really hard to see on there, but hopefully you guys can do that on your own. If you cannot, either after class or during my office hour, you can Zoom or Skype with me, and I can show you how to do it that way. But you're going to need to be able to do this on your own at some point to plot the sequence. So the next one is -1 to the n times n factorial over 2n. So now these are flipped. So I'm going to cheat here on Mathematica. Just put this thing to the negative 1. And I run it again. Now you can see the values are getting further apart. So in this case, we would say that this guy is now diverging. Where is the factorial located? The factorial is under math, then scroll all the way over to probability, and then the fourth option down. Do we always read these charts from left to right to see if it's diverging or converging? Absolutely. You're always starting from 1 to 10, or whatever they tell you to look at. So this one said the first 10 objects in the sequence. Thank you for typing that into the thread. I know there's a delay. Are you having trouble hearing me? Okay. All right, so those are those two sequences. You guys, if you need to, should try to plot them in your calculator to get used to that. So the next thing we want to look at, what do we have here? Mobile has a delay of 10 seconds, okay. When I hit graph, it gives me an error. Was there something else? You may want to check your parentheses and how you put in the problem. So make sure to put parentheses around negative 1, or sorry, negative 1 to the n. So it should be around the negative 1. And then you need parentheses around n factorial. That might be the biggest problem. So try that, and if that doesn't work, then like I said, we can do a video conference after class if you need some help with that. All right, so we've plotted sequences. We've determined whether they converge or diverge graphically. Now let's make sure that we can do this analytically. So to do that, we've got to take the limit as n approaches infinity of the sequence. And it says here, if L exists, the sequence converges. Well, that basically just means if you get a number out of it. For L to not exist, that would mean something like infinity, negative infinity, 0 over 0, that sort of thing. If we get that sort of stuff, then we would say divergent. So, determine if the sequence is convergent or divergent. If it converges, give the value it converges to. For a sequence, the value that it converges to is simply found by whatever the limit is. All right. So I just need to take the limit as n approaches infinity of 3n squared over, and I made a mistake here. Let's make this 7n. Otherwise, it'd be kind of silly to write it that way. So 3n squared over 1 minus 5n squared plus 7n. So if I'm taking an infinite limit and I've got powers of n, the easiest way to do this is divide by the highest power of n in the denominator. So I'm going to divide everything here by n squared. Sorry, this is a minus 5. Doesn't look very clear there. Okay. So now I can use the fact that the limit as n approaches infinity of anything that's 1 over x to the r let's see, I don't want n there, I want x, goes to 0. Which means now that this term here and this term there will both go to 0. So this is limit n approaches infinity, 3 over minus 5. This has nothing to do with the limit, so it is just minus 3/5. So if you were to plot that sequence and do it for very large n, you should see that it's approaching the line y equals negative 3/5. Any problems with that? So either everybody left the chat or no comments. So I'm going to go ahead and move on to the next one. Oh wait, is that 1 over n squared? Yes, this is 1 over n squared, sorry. The top right was just using the fact that you learned that in Calculus 1, and it says that anything that's 1 over x to a power, as x approaches infinity, equals 0. So not x to the n, but x to the r. If you wanted to call it n, you could have done that. It just, I wanted to stay away from n since we were doing it already in the problem. Come on. All right, so here we have a square root involved. We're once again going to introduce the limit. So we've got limit n approaches infinity Yes, it converges to -3/5. Thank you guys for promptly answering questions as well. There are a lot of things I'd like them to add into tuition. I'd also like them to pay for this whiteboard and the webcam. Alright, so once again, I'm taking the limit, an infinite one, something like this. I want to take the highest power of n and divide every term by it. However, when I put n squared inside of the radical, n squared is equal to the square root of n to the 4th. So when I divide inside here, I'm dividing by n to the 4th. When I do it outside the radical, it is n squared. So maybe I should write the step in between. Okay, so this is the step between these two. If I divide up here everything by n to the 4th, and then everything out here by n squared, n to the 4ths cancel there, n squareds cancel, and you get rid of one of the n's there. Resulting in this, when I take this limit, anything that's divided by n to a power will go to 0 when I take the limit as n approaches infinity. That leaves behind square root of 2 on top, 5 on the bottom. So this converges to that point, or that line. Any questions about that one? All right, seeing a lot of no's, so I'm going to go ahead and erase that. Right. Part C, limit, or sorry, the log of n squared over n. So again, I'm just taking the limit as n approaches infinity of the natural log of n squared over n. If I tried to do this directly, I would get infinity over infinity. That is L'Hopital's rule. And so I need to differentiate the top and the bottom. But before I do that, I'm going to take that 2 there, and I'm going to bring it down in front so that I don't have to do chain rule. So, L'Hopital's rule says take derivative of the top and the bottom and apply the limit again. So derivative of natural log of n, that is 1 over n. And the derivative of n is 1. So it looks like this time I get the limit as n approaches infinity of 2 over n. That is then going to just become 0. Right? Because 2 divided by infinity heads towards 0. So the limit of this function is 0. Also, one thing I think I forgot to mention when we got started was that I plan to scan my personal notes of these problems after I'm done with them and send them to you as well. So if there's something you can't see on the board or want better clarification on, or just want to do it again and you don't want to watch the video, then hopefully you can use that as well. Alright, I'm going to go ahead and I think there's a part D, so let's do that one. This also converges. As long as we get some number out of it, it converges. So that's n squared e to the minus n. So once again, limit n approaches infinity, n squared e to the minus n. I also know we're only about 50 minutes in, but I just wanted to ask quickly, how is this format working for you so far? Do you like it? Do you have other suggestions? So I'm just looking at the responses here. I'm going to go ahead and keep working the problem, but please keep answering. Better than my other professors. That's good. I like that one. As long as we can see, it's good. Well, that is the goal. What is it that you can't see? You mean if you have a problem with internet or the lighting, which I know is a problem? So I want to take the limit of this guy, and to do that, if I tried right now, I would get some infinite number times 0. That's not very good. Arthvy, it's only my third time teaching class this way, so don't feel bad. And sorry your internet is bad. I'm sure a lot of us are having trouble with that, considering how many people are working from home. It's full-on zombie apocalypse we're going through. Alright, so if I tried to take the limit here, I would get this. And what does that mean? I have no idea. I hope that you don't have an idea, because I've never heard anybody try to explain that to me. So we have to do this a different way. Well, we just got done doing L'Hopital's rule. We can do this one that way, but we have to rewrite it. Notice this is e to the minus n. So this would be n squared over e to the n. All right, if I rewrite it that way. And now if I tried to plug in infinity, what happens? Well, I get infinity over infinity. That's fantastic. That's one of those, oh, what's the name? I can't think of it. Improper forms for L'Hopital's rule. And so that tells me I can go ahead and differentiate the top and the bottom and evaluate the limit again. So this is now limit n approaches infinity 2n over e to the n. Plug in the limit once again. And oh surprise, we get infinity over infinity. So differentiate one more time. This one also converges. Let me quickly see if I have these notes already prepared. I want to see if there was one that was meant to diverge. Give me just 1 second. So I'm not sure if I asked, how's everybody doing? Now it appears all of them converge. So I'll have to think of one that diverges. There's probably one on the homework. Yeah, I understand work not being the greatest. Either having to go in and be around a bunch of people or just strange circumstances. All right. So what was the point of doing sequences? Well, we had to learn sequences in order to do a series. And the reason for that is a series is nothing more than the sum of a sequence. So here's just some examples, and I'm not sure how many of you are familiar with the summation notation. So this is sigma. That means a sum. And this one here runs from 1 to 3, which means you're plugging in I equal 1, so 1 squared. Then the sum says add to that, plug in every number until you get to 3. So 1 squared plus 2 squared plus 3 squared. The second example there says we've got a summation that runs from 5 to 9, so 5, 6, 7, 8, 9. Notice it's got this -1 to the k in front. We're going to come to find out that that's going to turn into an alternating series. And you can tell we've got a -1, +1, -1, +1. So that alternates in sign. So positive then negative or vice versa. And you just plug in the numbers and come out with a value. Any questions about what it means to be a summation or how you evaluate the sum? I most likely won't be having you evaluate the sum in that manner. It's a possibility, but not something I think is going to be a sticking point. So those series were finite. They ran over a short number of values. We can also have an infinite series, which typically runs from 0 or 1 to infinity. It could be any number, but typically 0 to 1. If it runs from 1 to infinity, you don't actually have to write it. You can write it as just a summation. And then just like sequences would converge and diverge, the series converges if you get some L that's a real number. So again, if you get a number out, 5, -1 million, 1/3, that's convergent. 0, convergent. To diverge, it's got to be plus or minus infinity. One important point is that there are many series that are convergent, but the value L to which it converges, we either cannot be found or is not important. So I'll tell you right now, there are 2 series that we will find the sum for. 3, sorry, there are 3 total. All the other series, we will not have to find the sum. So we can go ahead and start learning some of those series now. The first one is called the geometric series. And it's called geometric. The form is a times r to the n, which really just means every single one of the terms has an a in it, which I always thought was kind of funny that they never chose to write it this way. Because technically that a doesn't have to be in there if it's multiplied by every single term. But when we're doing these problems, we're going to want to identify the a and the r, and we need those because if the series converges, we can find its sum. So for the geometric series to converge, we need the absolute value of r to be less than 1. So a group divergent sequences yields a divergent. Let's see. So to answer your question, Tom, in the best way I can, a series is the sum of a sequence, not the sum of sequences. So if a sequence diverges, that doesn't necessarily mean that the sum won't. So don't intertwine the two necessarily in that manner. All right. So if the absolute value of r is less than 1, we can say converges for a geometric series. You will need to remember that. And the sum of that series is equal to this, a over 1 minus r, if the sum starts at 0. Now I'm going to change some of these in the packet. If the sum starts at, say, 1, then the sum for that series is AR over 1 minus R. And in fact, if that starts at 2, then you get A times R to the second over 1 minus R. But the only ones I'm going to have you deal with are 0 and 1. So, so if the absolute value is less than 1, it converges. If it's greater than or equal to 1, it's divergent. So really, we just care if it converges, because if it does, we can find the sum. If it diverges, we just say diverges, and we're done. The key to these problems is we have to get it in the right format. So let's take a look at this first one. Let me go ahead and erase what I've got here on the board. Okay. So looking at this, I've got something that looks sort of like a constant times some ratio to a power, but I've really got that n minus 1 up there, and that's throwing stuff off. So the question is, how do I combat that? Well, I can rewrite this sum as 3/5 to the n times 3/5 to the negative 1. Then I can take this 3/5 to the negative 1, flip it over. I can make it 5/3. So yes, you can split it up. And then I'm going to go ahead and put these two together. Sorry, the marker's squeaking. So this is now in the form where I've got A and I've got R. So once I have those, first I have to determine, is it convergent? Because if it isn't, there's no point in finding this. And I'll tell you, that's one of the things I've noticed a lot of students do, is they'll go, I tested convergence, it's divergent, and then they'll give me a sum. there is no sum if it's divergent. It's some infinite number. So we take r, which is 3/5, and we say, is the absolute value of 3/5 less than 1? Obviously it is. So if that's the case, right, that is true, then we can go ahead and find this guy, because this converges. And then our sum equals, now we have to pay attention to where our starting point is. Here it is at 1. So if we're starting at 1, remember that the sum is AR over 1 minus R. So this is 10/3 times 3/5 all over 1 minus 3/5. After all that, you get 5. Let me get my shadow out of the way so you can see it. So any questions about that problem? I'm sorry if there are long pauses in the video. I'm trying to give a chance for the chat to catch up to what I'm saying. Well, of course you're good to go, Parthvi. You already got this written down. But thank you for answering. All right, I'm going to go ahead and erase this, and I'm going to do another one. All right, so this one, I'll leave this one at 1. I'm going to change the next one to start at 0. Let's go ahead and do this part B first. So once again, I need this to look like, am I in the, yeah, I'm writing right in that glare. Need that to look like that. Right, some A times R to the N. So to do that, I need some fraction here. Right, R is basically a ratio. So the key to this one is 1 can be written as 1 to the power n. Which means I can go ahead and write that entire thing now as 1 over root 2 to the n. Okay. That means that a is 1, because there is no number out here besides 1. R is 1 over root 2, if you prefer, square root of 2 over 2. Once you have R, you need to determine is the absolute value of square root of 2 over 2 less than 1. Well, square root of 2 is 1.4 or something. So 1.4 divided by 2 is less than 1. So this converges. And if it so question was, so only since numerator is 1, the whole thing can be raised to n. Yes, I can rewrite it as to power n because of that. If it was a 2 up there, I could not do that. Right, the idea is that 1 to the n is 1. Okay, so that converges. We can then find its sum. Because we're starting at 1, it is AR over 1 minus R. Yes, sneaky algebra tricks, absolutely. A is 1, R is root 2 over 2. Then we have 1 minus square root of 2 over 2. I'm just going to go ahead and leave it. Actually, at the very least, I'm going to go ahead and multiply everything by 2. So this is root 2 over 2 minus root 2. And I'll just leave it right there. So again, it's just a matter of getting in the right form and then determine does it converge or diverge and then find its sum. I'm going to go ahead and do part C. Why multiply by 2? Just to get rid of the extra fractions. Anybody else just notice I tried to erase the problem? Alright, now this one's a little interesting. And I would typically let you guys do this one, but because we don't have our groups and boards and I can see what you're doing, I think I'm just going to go ahead and do all of these for you. If you have a different idea how you'd like to do things, feel free to tell me. Now this one is interesting because I've got this 2 to the n plus 1 up here. Well, I can break that up, and also I want to start at 0, not at 1. So in your notes, change that to, as it focuses again, to a 0, not a 1 there. Okay, so I'm going to change this to a 0, Now 2 to the n plus 1, that's 2 to the n times 2. That's all multiplication. Let me go ahead and slide that over. It looks kind of hard to see there for you. Too late to boot. I'll give you the next one to try. All right, so 2 to the n plus 1 I've rewritten as 2 to the n times 2. That is all multiplication and division, which means I can write it any way I like. And by that I mean I can pull this 2 out in front. So 2 out in front, and then I've got 2 over 7 to the n. So then I can say this is A, that's R. It's pretty clear here that the absolute value of R is less than 1. That's a converge. Sum is A over 1 minus R in this case because I've started at 0. So this is 2 over 5/7 or 14/5, if I'm not being silly, for a sum. Any questions about that one? All right, thank you. How does this red show up? Not at all. Fantastic. Blue. Nope, can't see that too well either. All right. Scoot that down. Looks like it's in the glare. I guess I can see it okay. All right. Make this 0 again because I want to. And I make the decisions around here. All right. We got e to the n plus 1. I can break that up as e to the n times e. Pi to the n minus 1 is pi to the n times pi to the minus 1. I really need the e and the pi to the n to be together. Then I can take this pi to the minus 1 up to the numerator, and I have pi e out in front here. So A is pi times e, R is e over pi. E over pi, that's 2.7 over 3.14. That is convergent. The sum, because I'm starting at 0, is pi e over 1 minus e over pi. Again, to clean it up, to get rid of that fraction, I'm going to multiply every single term by pi. That is our sum. Right, so nothing too drastic here. We're basically just doing algebra. All right. Let's go ahead and try the next one. Here I've got from 1 to infinity. So I've got to break this one up again. We've also got this 3 to the 2n instead of 3 to the n. I can rewrite that as 3 squared to the n power. Then I'm going to rewrite the 2 squared minus n as 2 squared. And I'm going to go ahead and throw 2 to the n down here. So that is 2 squared gives me a 4 as my a. This is 9 to the power n over 2 to the power n. So that's 9 over 2 to the n. At that point, this one is quite simple, because if that's r, the absolute value of r, is greater than 1 here. It looks like it's very hard to see. Rewrite that. This marker's dying. Yeah, there we go. Absolute value of r is greater than 1. So I'm done. This diverges. Give me just a second. It appears my power cord has come unplugged. There we go. I just had that happen. Okay. Well, dang, Ken. I wish I could join you. Guess you wouldn't know, right? All right. So any questions about this problem? Tom, going to you. All right, I'm going to assume that's a no. Now I've got 5 to the n minus 4 to the n over 7 to the n. So every problem up until this point, I've been able to break it up such that I could rewrite it, but they were multiplications. Is this marker working yet? Yeah, there we go. Okay, so this one, because of this minus sign here, I can actually break into two summations. So the sum can become two different ones, like so. And I know there's a little glare there, but in my screen I can see it okay. Is everybody else okay? All right, thank you. So if I break it into two, then I need to test each one of them individually. So this one I can rewrite as 5 over 7 to the n. The second one, 4 over 7 to the n. And each one of them has a value for r. Each one of them is less than 1 absolute value. Therefore, they both converge. And therefore, I can find the sum for each one of them. So if you want, you could maybe say sum 1 and sum 2. Right, one for each of the summations. And add them together. Sum for this one is, because we're starting at 1, A, however, is 1 in both of the problems, so that doesn't matter. And then this one is 4/7, or 1 minus 4/7. So, let's see, 5/7. This would give me back 2/7, or multiply by 7/2. So that results in 5/2. This is 4/7 divided by 3/7, which is like multiplying by 7/3. This results in 4/3. Yes, Ken, they both have to converge. If one diverges, the entire original series diverges. So I don't care if this one converges. If this one then diverges, the whole thing's done. So for instance, all I would have to do is make this number right here an 8. That series would diverge and make the entire original series diverge. So then at the end, I just need to add up the sum. Let's see. $23.6 if I'm not losing it. It's quite a possibility at this point. Why wouldn't you subtract? You would subtract, Ross. I forgot to put that minus sign in there. Thank you for reminding me, sir. And I love that there is now internet proof that I made that mistake. So minus, minus, and that's 7/6 now. So did everybody hear me when I mentioned about if one series diverges, the whole thing diverges? And Parthvi, is that a joke, or are you saying that it's you can't see the stream any longer? Okay. All right. So let's see what else we got here. I couldn't see the screen. Oh man, I just started erasing it. Don't worry, the video will be there, and I'll work the problems and put them up tonight. Does not want to erase. So you guys might enjoy this while I'm trying to prepare for the next problem. I went to go get this board yesterday, and I had to take my mom's Subaru because my car is too small. It's not big enough for me to put this thing in there. And the genius that's working there pushed it in the back of the car a little too fast, and it has metal edges. Kind of carved out a little section in the side of the car, on the inside, thankfully. But still, I had to explain that to the madre. Really, I cleaned the screen for this guy. All right. So I've got one more series for you. I'm going to go ahead and just do one example, I think, and then I'll let you guys try the other one. I'll leave the last few minutes for questions of any kind. So these are called telescoping or collapsing series. And the reason for that is, as you see here, it says almost all of the inner terms are opposites. Tom, yes, this content will not be on the second test. If the series is telescoping or collapsing, you can write out several terms and evaluate the limit of the sequence. The limit should go to 0. If it does not go to 0, it diverges. If it diverges, we can't continue to find the sum. There's no point in doing the partial fraction decomposition at that point. So, for this type of series, first thing we need to do is evaluate the infinite limit. And then, if it converges, meaning limit 0, we're going to do a partial fraction decomposition. We'll see all of the values that are going to disappear, and we can get the sum. Let me make some space here. Oof. All right. 1 over n times n minus 1. first thing is to look at the infinite limit. So the limit, as n approaches infinity, 1 over n times n minus 1. What do you think that's going to give me? All right, that's going to be 0. Okay? So if it is 0, this converges, and I can continue to find the sum. We need to do the partial fraction decomposition. To do that, remember we need a over n plus b over n minus 1. This has to equal 1 over n times n minus 1. Multiply a by n minus 1 plus b times n. And that all has to end up equaling the numerator, which is 1. So this is going to give me an minus a plus bn. Put the a and bn together. So, this right here tells me that negative a has to be 1, or a is negative 1. A plus b has to be 0 because there are no n terms on the right side. So a plus b is 0. Therefore, b is equal to negative of a. A is negative 1. Negative of a negative 1 plus 1. That's A, that's B. Plug them back in, put them back in the sum. So then I've got the summation n equals 2 to infinity minus 1 over n plus 1 over n minus 1. So if I want to find the sum, I'm going to start writing out the first couple terms. Well, the first term is when I plug n equal 2 in. This is minus 1 over 2 plus 1 over 2 minus 1. I'm going to keep these grouped. Plus, now plug in the next term. That's when n equals 3. Negative 1/3 plus 1 over 3 minus 1. Let me do 2 more quickly. Plug in 4. Actually, I think I'll stop there. Let's look at this now. Minus 1/2 here. This 3 minus 1 down here is going to give me a 2. So that's positive 1/2. So negative half, positive half. Then I've got negative 1/3 plus 1/3. You can then guess, or if you prefer to keep writing out terms, that this term is going to cancel with the next set. The only thing that's going to be left is that term right there, and it's going to be equal to 1. Now, technically, the term all the way at the end is going to have a term left behind. However, because we are heading towards infinity, the infinite term, right, is going to turn into zeros. So there's nothing left behind out there. If this wasn't infinite, then we would have something left behind on the other end. You won't have to worry about that for this class, though. All right. Sorry that took me a little longer than I wanted. I would like you guys to try B on your own. We've got about 5 minutes left of normal class time. Please take that time to ask me questions. Please give me feedback on how things went today, how I can improve it for you, anything that you got for the next 5 minutes. And at that time, I'll go ahead and shut off the chat or turn off the stream, and I'll get to work on these notes so I can get those up to you. And I got some other stuff I got to do for my other classes and so forth. Also, if any of you need to ask me any specific questions, you want to talk face-to-face, we can do a Zoom or Skype meeting. All right, Ken. When we're done, if do you have Zoom? If you do, you can send me a invite via my email for the school, and I will work with you to work on that calculator problem. Quiz. The quiz. I haven't decided on exactly how I'm going to do it yet. I'm going to get that to you as soon as I can. In the future, I may try to do something where I post something right before the scheduled class time and then say, okay, you have 20 minutes. It has to be in my email within that 20 minutes. Like just a picture, something like that. I'm glad you thought it worked well. Thank you. Anybody else still here? Only saw about maybe 5 people actually being active. I guess maybe about 7 or 8. Hi Ross, I know you were there. So anybody else want to express anything? Went well, didn't go well? I should use some other streaming? You'd rather just videos? I might have to drive somewhere and steal their internet so I can follow along. I missed half the content. Well, don't do it in my name. I know that the public schools were supposed to be sending hotspots home with children. I don't know if Hartford is offering anything like that. You could try and call and see if you can get some information about that. Maybe ask the dean. All right, guys. I'm going to go ahead and let you go. It's 4 o'clock. Thank you for tuning in. Hopefully it helped you a little bit. I will be in touch, and I will see you on Wednesday.